Alright, so today we're going to be solving a min-max problem. The problem reads, find two non-negative numbers whose sum is 9, and so that the product of one number and the square of the other number is a maximum. I got this problem from the University of California, Davis, and I'll make sure to leave the link in the description. So from the question, we understand that the sum of the numbers must be 9, and that the product of one number and the square of the other number must be a maximum. So things to note are that we are going to square one number, and we must ensure that the product is indeed a maximum. So we can represent these two numbers using variables. We can let x represent the first number and y represent the second number. From here, we can create two equations. The first being x plus y equals 9, as the sum of the two non-negative numbers must be 9. And the second would be x times y squared equals p, as the product would be between one number and the square of the other. So let's start with the first equation, x plus y equals 9. We can isolate for y using this equation by subtracting x from both sides, so we get x plus y minus x equals 9 minus x. From there, we can cancel out the x's on the left side, and then we're left with y is equal to 9 minus x. Alright, so what about the second equation, x times y squared equals p? Well, we can sub in y equals 9 minus x from our previous equation, then we get x times 9 minus x squared equals p. We can expand this, multiply 9 minus x by itself, and then we get x times 81 minus 9x minus 9x plus x squared, which we can simplify to p equals x times x squared minus 18x plus 81. Now, this isn't very convenient to work with, as we have a lot of different terms, so as a shortcut, you can just say p is equal to x times 9 minus x squared. Now this will be useful when it comes to solving the problem. Keep in mind that the question states that the product of these numbers must be a maximum. Effectively, this product acts as a quadratic function, and as for any function, to find any local maxima or minima, we must set the derivative of the function to 0. So first we have to calculate the derivative of this function here, or p prime. So to determine p prime, we can employ product rule. We take the derivative of x, multiply that by 9 minus x squared, add x multiplied by the derivative of 9 minus x squared, and then we get 1 times 9 minus x squared plus x times 2 times 9 minus x times negative 1 equals p prime. So here we employ exponent rule. We bring the exponent 2 here down and subtract the exponent by 1, and then we take the derivative of what's inside these brackets, 9 minus x, which will leave us with 0 minus 1, which leaves us with just negative 1. To simplify even more, we can bring the 2 and negative 1 to the outside, multiplying that by x. So then we get 9 minus x squared minus 2x times 9 minus x equals p prime. And then finally, we can factor out the 9 minus x from both of these terms, which just leaves us with 9 minus x times 9 minus x minus 2x. And finally, we're left with p prime is equal to 9 minus x times 9 minus 3x in a perfectly factored form. So what we do with this is we let p prime equal 0. As we previously mentioned, to determine local maxima and minima of a function, we have to let the derivative equal 0. So we say 0 is equal to 9 minus x times 9 minus 3x. From here we have two possibilities. Either 9 minus x is 0, or 9 minus 3x is equal to 0. Let's start with 9 minus x, as this will be very simple. All we have to do is add x to both sides, and then we end up with x equals 9. As for this side, we can add 3x to both sides. We get 3x equals 9. Divide both sides by 3, which allows us to cancel out the 3 from 3x. And then we're left with x is equal to 3. So from here we have two possibilities. Either one of the numbers is 9 or 3. So again, we have to keep in mind that x represents the first number and y represents the second number. And keep in mind that we set y equal to 9 minus x from our first equation, as shown here. So again, our two possibilities are x equals 3 or x equals 9. So we can branch out. We either have y equals 9 minus 3 or y equals 9 minus 9. This leaves us with y equals 6 or y equals 0. From here, we can test our second equation, where the product of one number, x, and the square of the other, y, equals p. So from here we can sub in the values of x and y into equation 2. So I either have p is equal to 9 times 0 squared, which means p is equal to 9 times 0, which effectively means p is 0. And with our second possibility, we have p is equal to 3 times 6 squared, as x is equal to 3 and y is equal to 6 in this case. So then we have 3 times 36, which will leave us with p is equal to 108. And from here, we can observe that 108 is a much greater number than 0, which means to ensure that the product of one number and the square of the other is a maximum, we must select the larger p-value, which in this case is p is equal to 108. So from here, we can conclude that x equals 3 and y equals 6. So to summarize, the two negative numbers are going to be 3 and 6. Thank you for listening, and make sure to follow for more math solutions.